In our next story, we continue the theme of celebrating interesting technologies by looking at pyrolysis. Now, last month, we showcased a technology solution from Organics Group which looked at ammonia recovery. And note, I say recovery, not removal. It was about generating an ammonia-rich fertilizer product. Well, this month, we're staying with Organics to hear about their pyrolysis technology. And here again is Rob Eden, and I open by asking him to explain what pyrolysis is.
Robert, now we saw you a couple of months ago where you kindly shared what you've been doing around ammonia recovery, especially using waste heat to create this turquoise ammonia, which was fascinating. Today we're going to talk about a different thing. We're going to talk about pyrolysis. Now, what is pyrolysis?
So pyrolysis is the thermal conversion of organic materials into carbon char and ash in the absence of air. So it's not burning. It's I sometimes say it's like melting, but without the liquid.
Excellent. And the biochar that's generated is a valuable product.
Yes, the biochar can be a valuable product. In order to earn carbon credits, it needs to be a waste material. So you can't grow a crop and convert it to biochar. You have to use waste materials, such as sludge from an anaerobic digester or from a sewage treatment works. That's a perfect feedstock.
Yeah, and I assume it solves some other problems around microplastics and PFAS and things like that.
Yes, absolutely.
Great. All right. So what's special? I mean, pyrolysis is something that people have been using for many years. What is it that's special about what you do at Organics?
Well, we've been working on pyrolysis for about 20 years in actual fact, and we've developed a technology which is economic and efficient. So you can meet the price point required to be viable. And we also include a drying technology which again uses heat recycling to minimize the heat load. So because obviously sludges are very wet, and that's a big problem for pyrolysis. You have to dry it, but we include a method of drying which enhances the overall process.
It's funny, isn't it, how the innovations you've created at Organics in pyrolysis and also in the turquoise ammonia sort of hinge off doing clever things with heat recovery, just because that's what suddenly changes the economics from being abhorrently expensive to attractively attractive.
Yeah. Well, when we started out, heat was wasted, and even landfill gas was wasted, and biogas was wasted. All these things were wasted, and now suddenly they're all valuable resources. So we've had to become more efficient and more effective in using heat to minimize the use of the resource.
All right, well, I get it. Okay, so you've got the gasification / pyrolysis process. It generates the biochar. Let's talk about what happens to the biochar. What can one usefully use it for?
Well, there's no limit to human imagination. So the standard is fertilizer, but carbon credits can be earned from adding biochar to asphalt, to concrete, to various cement blocks, anywhere where it's locked away, so it's not consumed. You can't, for example, burn the biochar and use it as a coal. But anything where you lock it away, that has value.
And because of that, does that mean it creates negative emission targets if you're locking it away, if you're sequestering?
Yes, absolutely. So 1 tonne of biochar can produce about 3.5 tonnes of carbon sequestration. And each tonne of carbon sequestration is worth between 100 to, well, it depends, 100 to $150. So 1 tonne of biochar has the potential to earn $450, $500 through the sale of carbon credits, as long as it's sequestered.
Okay, so let's put that into the context of a typical sewage treatment plant. 200,000 per population sewage treatment plant. That would produce roughly 50,000 tons of dewatered sludge every year, which I think, if you've given me those numbers right, that would be about 4,000 tons of biochar. Is that right?
Yeah, that's right. And each tonne of biochar has about 40–50% carbon. So the carbon content of the biochar is what gives you the carbon sequestration credits.
So I have my 4,000 tons of biochar, 6,000 tons of CO2 being locked up, and then a fertilizer. Do we have any idea of how much fertilizer value might come from a works of that size? What the commercial value of that might be in pounds?
Well, again, that varies, but the total value is going to be about 2 million pounds a year of a 200,000 PE sewage treatment works.
Okay.
Capex.
And how much will that typically cost? Are we talking 50 million or 10 million or 2 million?
Well, no, again, it depends on the specifics of the situation, but the ballpark figure is about 5 million.
£5 million sterling. Felt a lot lower cost than I was expecting. You agree? Thank you, Rob. Great to have that information shared, and we wish you the best. With the increased attention on things like PFAS in biosolids, I'm absolutely certain that you'll get more interest over the coming year.